Hey everyone, and a big hello to all you STPM students out there. Today, we're going to tackle something that looks a little scary on paper, but I promise you it's one of the most straightforward problems you'll come across. We're talking about first-order linear differential equations. Stick with me, and by the end of this, you're going to have a rock-solid method to ace these questions in your exams.
So, here's how we're going to do it. First up, we'll figure out what this linear equation challenge is all about. Then, I'll show you the key to unlocking it, which is the integrating factor. We'll walk through a 5-step solution method, put it to the test with an example, and then wrap up with how you can master this whole technique.
All right, Section 1, the linear equation challenge. So what exactly are we trying to solve here? Before you can solve any puzzle, right, you've got to know what the pieces look like. Let's break down what first order and linear really mean.
Okay, this is it. This is the standard form, and it's going to be your best friend. Your number one goal always is to make your equation look exactly like this: dy over dx plus p of x, y equals q of x. The two bits you absolutely need to hunt down are p of x, that's whatever's sitting next to the y, and q of x, which is just all the stuff on the other side of the equal sign.
Now, what about that word linear? Don't let it scare you. It's actually super simple. All it means is that the y and its derivative, dy dx, are just, well, themselves. They're not squared, they're not multiplied together, there's no funny business. They're just plain old y and dy dx to the power of 1. That's it. Nice and simple.
Okay, moving on. Section 2 is all about your key, the integrating factor. I like to call it the secret weapon for these equations. So how do we actually crack this code? Well, we use this special tool that's designed to do one job and one job perfectly.
And here's the formula for that secret weapon. We usually just call it the IF for short. It's e to the power of the integral of px dx. Now I know what you're thinking. That looks a bit messy. But trust me on this. Once you've got your px, plugging it in and solving this is just a routine step. It's not as bad as it looks, I promise.
So, why? Why do we go through all this trouble to find this thing? Well, this is where the magic happens. The entire point of the integrating factor is to clean up the left side of our equation. When you multiply by it, it magically transforms that messy dy dx plus p of xy part into something beautiful. The derivative of a simple product, d dx of if times y. It turns a tricky problem into one we can actually integrate.
Section 3. Let's get into the 5-step solution method. This is your step-by-step guide to the answer. Think of it like a recipe. You're not guessing here. You're just following the instructions. You do these 5 things in order every time and you'll get the right answer. Okay, here's the plan. Step 1. Get it in standard form. Find your p of x and your q of x. Step 2. Find the integrating factor. Step 3. Multiply the whole equation by that if. Step 4. Integrate both sides. And finally, Step 5. Just solve for y. That's it. That's our roadmap to the answer.
All right, theory's one thing, but let's get our hands dirty. Time for Section 4, Method in Action. We're going to solve one together right now. So, if you can, grab a piece of paper and a pen, and let's work this out. Our equation is dy over dx plus y equals e to the x.
All right, step 1. First job is to identify p of x and q of x. So take a look at our equation, dy dx plus y equals e to the x. Now compare that to the standard form. What do you reckon p of x is, and what about q of x?
Did you get it? P of x is 1, and q of x is e to the x. If you got that, you're exactly right. Remember, p of x is just the number in front of y. Since we just have y, it's an invisible 1, and q of x is the easy one. It's just whatever's on the other side. Boom. Step 1 is done. Okay, on to Step 2. It's time to find our integrating factor. Remember the formula? IF equals e to the integral of p of x dx. We just found that p of x is 1, so what's our IF? Go on, pause for a sec and see if you can work it out.
And the answer is e to the x, because the integral of 1 dx is just x. So our IF is e to the power of x. Perfect. We've got our key, now let's use it.
All right, Step 3, time for that magic trick. We're going to multiply the whole equation by our IF, which is e to the x. And just like we said, the left side instantly cleans itself up and becomes d dx of e to the x times y. On the right side, we get e to the x times e to the x, which is just e to the 2x. Look at that, so much simpler already. Okay, Step 4.
Our equation is looking great. It's perfectly set up for integration. We've got this d dx thing on the left that we want to get rid of. So, what's the opposite of differentiating? Yep, we're going to integrate both sides.
So when we do that, the integral and the derivative on the left just cancel each other out. We're left with e to the x times y. On the right, the integral of e to the 2x is 1/2 e to the 2x. And this is super important, so don't you forget it. We have to add the constant of integration. Always add that plus c. You do not want to lose easy marks on that one.
We are on the home stretch now. Step 5. Look at what we have. We're so close. The goal is to get y all by itself. So what's the last little bit of algebra we need to do to make that happen?
You just have to divide everything by e to the x. And when you do that, you get the final answer, y equals 1/2 e to the x plus ce to the negative x. And that's it. We did it. See? You just followed the 5 steps and got the solution. Awesome work.
Okay, fantastic. So now for our final section, mastering the technique. Seriously, solving these is all about the process. So let's quickly go over the key takeaways you need to remember for your exam.
Here's what you need to burn into your brain. Number 1, always get it into standard form first. That's non-negotiable. Number 2, the whole job of the integrating factor is to clean up that left side. That's its only purpose. Number 3, do not forget the constant of integration. That plus c. It is essential. And finally, number 4, just trust the 5 steps. They're your guide. They will not let you down.
So there you have it. You now have the tool to solve these equations. But to really test your understanding, here's a little something to think about. How would this whole method change if q of x was just 0? What would that do to the process? Give it some thought. Keep practicing, and you are going to be a pro at this. All the best.